I see it now. Okay. Okay, so welcome everybody. In section 5.7.4, we're going to talk about confidence intervals and sample sizes for proportions. So in this section, what we're going to do is we're going to try and estimate the proportion of the entire population that has a given characteristic. And the way we do that is we start with looking at the portion of the sample population that has that characteristic. And we use the sample size, which we write as n, and X is going to be the number of people in that sample that possess that certain characteristic of interest. And then again, P hat is the sample proportion. So that's the proportion of people in this pool of N people that have the characteristic. So another way of writing that is that P hat is X over N. And then to make these formulas a little bit simpler to look at, we use the symbol Q hat to be the people that don't have that characteristic. So that's going to be just 1 minus P hat. Okay, so that's, again, that's just a simplification to make these formulas a little bit easier to look at. So let's just start with an example so you can see how we calculate these things. So it says a random sample of 200 workers found that 128 drove to work alone. So again, we want to figure out P hat and Q hat, the proportion of people that drive to work alone, and then the proportion of people that do not drive to work alone. That would be the proportion that drive with someone else. So N will be 200 because the random sample had 200 people, and the characteristic of interest was driving to work alone, so that's X equals 128. And then to calculate P hat, we just take X divided by N, so that's 128 divided by 200, and we get that P hat is 0.64. So that's 64% of the population from this sample are driving to work alone. And then Q hat is just 1 minus P hat, so that would be 1 minus 0.64. That's 30.36 or 36%. That's just kind of a gentle intro to what these things are counting. I talked a little faster than the right.
No, I totally got distracted. I stopped clicking. My bad.
Yeah, so just to recap, 64% of the people drive to work alone, 36% of the people do not. And so this is always looking at certain proportions where you're either in the characteristic group or you're not.
Okay, so there is a formula for building the actual confidence interval for proportions. So you can see that in your notes there. It's similar to, the confidence interval for means that we looked at in the last couple of sections. So we're starting with our sample proportion, and then we're basically going to subtract some amount. That's going to give us our lower bound, and then we'll add that same amount to the sample proportion, and that's going to give us our upper bound on our confidence interval. Rounding rule for proportions is always going to be 3 decimal places, so that's at least straightforward. We do have some assumptions. We're going to assume for all of these, textbook questions, the sample is random, and the experiment is binomial. So either you have the characteristic or you don't have the characteristic. It's got to be one of those 2 options. And then we also have the criteria where, in order to do these confidence intervals for proportions, the number of people who have the characteristic of interest needs to be at least 5. Same thing for the number of people who don't have the characteristic, needs to be at least 5. If either one of those is smaller than 5, then the confidence interval is probably not going to be accurate enough. Again, all of the questions you're going to get will have those satisfied, but just know that in the real world, if you're doing this, you would want to make sure that you're satisfying that. Okay, so let's do an example here. So example 2 says a survey of 1,404 respondents found that 323 students paid for their education by student loans. Find the 90% confidence interval of the true proportion of students who paid for their education by student loans. Okay, so let's jot down all the things that we're going to need to know to plug into that formula. So let's start with N. So N is the total number of people, which is the 1,404. And then let's figure out what X is. So X is the number of people who have that characteristic. So the number of students who paid for their education by student loans, so that's 323. P hat, we just practiced that in example 1. So that's just X divided by N. So 323 divided by 1404. Comes out to 0.230 when you do 3 decimal places. And then Q hat is just going to be 1 minus p hat. So 1 minus 0.230 is 0.770. Okay, and then there's one other thing we need, and that is the z alpha over 2. So we still have that critical z value when we're doing proportions. So just from that common list that you wrote down in your notes, for 90%, it's 1.65. Okay, so I think we're ready to plug in here. So we're going to start with p hat. That's the sample proportion. Okay, and then we'll minus the z alpha over 2, and then you times it by the square root of p hat times q hat divided by n. And I left off the zeros just because this is a really long formula and I was trying to make it fit on the screen. And it doesn't matter if you leave off zeros at the end of a number, but just know that you're not supposed to like round to 2 decimal places or anything like that. If you have actual three non-zero numbers, use all 3 of them when you're putting them in this formula. Okay, so that's going to be the lower bound on our population proportion. And then for the upper bound, you just copy the same thing over and change the minus sign to a plus sign. And then you type both those things into your calculator, and you'll get about 0.211 for your lower bound and 0.249 for your upper bound. Okay, so therefore we can be 90% confident that the percentage of students who pay for their college education by student loans is between about 21.1% and 24.9%. Okay, now we did the formula once, so let's never do that again. Turns out your calculator can do this one as well. So let's just redo this question now, but I'll show you how to just do it from your calculator in the very beginning, from the very beginning. Okay, so you go to stat, go over to test, and then you want to go down to 1 prop z int. So it stands for 1 proportion z interval. So you'll select that, and then it only needs a couple pieces of information, which is nice. It just needs to know what x is, what n is, and the confidence level. So x was the 323, n was 1404, confidence level was 0.9, and it's going to give you a final answer of 0.212 and 0.249. Okay, so Dr. Insko, does that match exactly what we got when we did it by hand?
No, it's slightly off.
Yeah, it's slightly off. And remember, as I talked about in section 6.3, the calculator answer is the more accurate answer. And that's because when we were doing the formula, about halfway through for p hat, I rounded to 3 decimal places. And just that little bit of rounding within the problem ended up throwing off our final answer a little bit. So it's actually better to just use the calculator from the beginning because that's going to give you the most accurate answer at the end.
Well, I thought I had to do because the critical z value was 1.645 instead of 1.65. So.
It could be that as well, but I think I also might have rounded that number.
Okay.
P hat. But yeah, that's a good point for 90% because we use a slightly inaccurate z value. That would also throw things off if you're doing it by hand. Mm-hmm. Okay, so let's do a couple now. Huh?
I said thanks, Connect Math.
Yeah. Okay, so let's just do a couple more examples for practice here. Let's see, do you want to take number 3?
Sure. It says a survey of 1,898 adults with lawns found that 45% of the adults said that dandelions were the toughest weeds to control in their yards. Find the 95% confidence interval of the true proportion who said that dandelions were the toughest weeds to control in their yards. This was probably not written for a Florida lawn because I barely even see dandelions, but those Florida snow are everywhere. Okay, so let's see here. So we have X is what? 45% of 1,898. Okay, so we weren't given we weren't given the value x. We have to calculate that now. But we were given that n was 1898. So to calculate x, we're going to take 0.45 times 1898, and we get about 854.1. Now, because we're going to be plugging this into a calculator, the one thing we should note is that it will not accept 854.1 as a number of adults. So you're going to have to round down to 854 there. And then we're going to type in one prop z interval, and we'll get x is 854, n is 1,898, and the confidence level is 95%. And so when we hit enter there, it should give us that p is between 0.428 and 0.472. So that's 42.8% and 47.2% for our confidence interval.
Yeah, so I'll just recap a couple of things there. So on some problems, it'll just straight up tell you like the number of adults or the number of people who have that characteristic. But on some, they might just tell you like the percentage. So in that case, you're going to actually have to figure out what that number is. So you'll do the percent of the total. And then if it comes out to a decimal, you do have to round that to the nearest whole number. So just normal rounding, do that to the nearest whole number. If you don't, what's going to happen is your calculator is going to tell you that there's a domain error. So if you are getting domain errors in this section, it's probably because you're forgetting to round to the nearest whole number for your x value.
Okay, cool.
Okay, so let's do example 4. It says a random sample of 205 college students were asked if they believed that places could be haunted. 65 responded yes. Estimate the true proportion of college students who believe in the possibility of haunted places with 99% confidence. According to Time magazine, 37% of all Americans believe that places can be haunted. Okay, so we're talking about proportions here. So we're going to go to one prop z int. And remember, your calculator only needs 3 pieces of info. Just needs to know x, n, and the confidence level. So x is the number of people who believe that places could be haunted. So we're told that number is 65. N is the total number of people, so 205. And our confidence level is 99%, so 0.99. So very straightforward question. You'll just put all that in. And it's going to give you a lower bound of 0.233 and an upper bound of 0.401. Okay, so you'll see that there is some other info in the question that we didn't use. So if you read that last sentence, it said, according to Time magazine, 37% of all Americans believe that places can be haunted. So in a lot of these questions in the section on proportions, the questions will give you like an extra piece of information that you don't necessarily have to use for the question. Okay, it's really just there for like comparison purposes. So on some questions, it might reference that statistic that they gave you, and they might say, all right, how does that compare with the interval that you got? You know, based on your interval, how believable is that statistic? So let's kind of compare this one. So Dr. Insko, how do you think that statistic compares with the interval that we got?
Well, it falls inside of it, but it falls to the high side of it, I guess. So.
Yeah, but I think the main thing to realize is that it does fall in it. So yeah, that does seem like a believable statistic, at least based off of the interval that we came up with. And just how do you know that 37% is between those two decimals?
Because it's 23.3% and 40.1%. And I would even believe that for a group of college students, that their belief in haunted houses or haunted places might be lower than the average population too. I mean, I think when in college you learn the scientific method, and maybe you learn to be a little bit more skeptical of claims like, oh, there's a ghost in my house.
Okay, true. Yep. So like I said, on some questions, they might have you compare with, that statistic. On other questions, they might not ask you about it or reference it at all. So just don't get thrown off if there is, an extra piece of info in the question. that you didn't end up using, whatsoever. Okay, and then we can also figure out the minimum sample size needed for proportions as well. So it's a different formula than the one for averages. This one is p hat times q hat times your z alpha over 2 divided by the margin of error squared. And just like before, we do want to round up if necessary so that we get a whole number. Okay, so let's do an example. It says a researcher wishes to estimate, and E still stands for the margin of error, just in case you forgot what E is. A researcher wishes to estimate with 95% confidence the proportion of people who own a home computer. A previous study shows that 40% of those interviewed had a computer at home. The researcher wishes to be accurate within 2% of the true proportion. Find the minimum sample size necessary. Okay, so we need to know P hat, Q hat, Z alpha over 2, and E, the margin of error, to be able to plug into this formula. So P hat is the proportion of people who had a computer at home. So it says 40%, so we're just going to turn that into a decimal, so 0.4 or 0.40, doesn't matter. Q hat is just 1 minus P hat, so 60% or 0.6. E, your margin of error, well, it says accurate within 2%. So you do need to turn percents into decimals in this section. So 2% would be margin of error of 0.02. And then Z alpha over 2 for 95% is 1.96. So we'll have that N equals 0.4 times 0.6 times 1.96 divided by 0.02 squared. And that comes out to be about 2,304.96. And then we're going to remember to always round up for minimum sample size. So we would want to sample a minimum of 2,305 people for this one. Now on part B, it says, assume that no previous study was done. Find the minimum sample size necessary to be accurate within 2% of the true population. So oftentimes, if you're doing a study, you might not have a previous study to, look back on. So in that case, what you're going to do is basically just assume that 50% of the people have the characteristic and 50% of the people don't have the characteristic. Okay, so you're just kind of splitting the difference there. So you'll notice that up there in the notes, I said that if there is no previous information, then you're just going to let both P hat and Q hat be 0.5. Okay, everything else stays the same. It's just those numbers you're going to let be 0.5. So E is still 0.02, your Z alpha over 2 is still 1.96. So to find N, you're going to do 0.5 times 0.5 times 1.96 over 0.02 squared. And now it comes out to be 2,401, and it does come out to be exactly that number. That was not rounded. It is a whole number there. So if you get a whole number, you don't have to round up, just keep it as that whole number. So we would need to sample a minimum of 2,401 people. And you can see that it's slightly, oh, sorry, I was gonna say that you could see that slightly more than when you knew the
previous information.
Yeah.
Seems like this book is really showing its age with some of these questions. Like,
oh, definitely.
The percentage of students who have to pay their college using student loans, or the percentage of people that have computers at home, I think has changed a bit.
Yeah, for sure. But that's why this is the last semester that we're using this book. So.
Yeah. Okay, so should we do some extra practice problems?
I think we should, yes.
Okay. Practice problem number 1, it says a nutritionist found that in a random sample of 80 families, 25% indicated that they ate fruit at least 3 times a week. Dear, I hope that's higher now. Find the 99% confidence interval of the true proportion of families who said that they ate fruit at least 3 times a week. Just to be clear, you should eat fruit a lot more than 3 times a week. But anyways, we have here that N is equal to 80 because that's the sample. And then we aren't given X, but we are given the percentage. So that's 25% of 80. So you take 0.25 times 80 and you should get 20. And then what we're doing here is we're trying to get a 99% confidence interval. So what we're going to do is we're going to use the one prop z interval function on your calculator, and we're going to put in x equals 20, n equals 80, and confidence level is 0.99. And we get a confidence interval of 12.5% or 37.5% as our bounds. So that's 0.125 or 0.375 as our upper bound. Is that clear, Karen? Am I missing anything?
No, that's good. Do you want to do part B?
Yeah. Okay. Yeah. I should say that like what we're saying is that we're 99% confident that the population mean falls between 12.5% and 37.5%. The proportion of people that eat fruit at least 3 times a week. But again, I think you're supposed to eat fruit more than 3 times a day, so that's kind of scary. Okay, so would a proportion of families equal to 28% be considered large? And my interpretation would be no, according to the data we're given, because that falls within our confidence interval. 28% is between 12.5% and 37.5%. So that's a no. I think that's all I have.
Yeah, I think that answered everything. Okay, number 2 says that a CBS News New York Times poll found that 329 out of 763 randomly selected adults said they would travel to outer space in their lifetime given the chance. Estimate the true proportion of adults who would like to travel to outer space with 92% confidence. Okay, so we just need to know X and N and the confidence level. So X is the 329, N is the total number of people, so 763. Confidence level is 0.92, so this is a very straightforward one. We really didn't have to do any work except put those 3 numbers into one prop z int, and you get, when you round to 3 decimal places, 0.400 and 0.463. So between 40% and 46.3%.
Okay, great. For 3, it says, in 1980, more than 35% of cars purchased had a manual transmission, aka a stick shift. By 2007, the proportion had decreased to just 7.7%. A random sample of college students who own cars revealed the following. Out of 122 cars, 26 had stick shifts. Estimate the proportion of college students who drive stick shifts with 90% confidence. Okay, so here we're given that is equal to 122 and X is 26. And then our confidence level is 90%. So we just need those 3 data points and we stick those into the calculator using one prop Z intervals. And we get a confidence interval between 0.152 and 0.274.
So is it a problem that you didn't use the fact that in 1980, more than 35% of cars purchased had a manual transmission?
Nope, I think that was just giving us a perspective of like how things have changed between 1980 and 2007.
Yeah, okay, good.
Yeah.
All right. Example 4 says that a researcher wishes to be 95% confident that her estimate of the true proportion of individuals who travel overseas is within 4% of the true proportion. Find the sample size necessary if, in a prior study, a sample of 200 people showed that 40 traveled overseas last year. Okay, so we just have to find N, P hat, Q hat, your margin of error, and the Z alpha over 2. That's all of those things you need for your minimum sample size for proportions formula. So N is the total number of people, which is 200. P hat is the proportion of people who traveled overseas. So that's the 40 out of 200, which reduces to 0.2. Q hat is just 1 minus P hat, so 1 minus 0.2 is 0.8. We want to be accurate within 4%, so your margin of error is 0.04, and Z alpha over 2 for 95% is 1.96. So we'll plug into our formula. So we have 0.2 times 0.8 times 1.96 over 0.04 squared, and you get 384.1. So Dr. Insko, I think my answer should be 384. Do you agree with that?
I mean, we should round up though, right? Because we're talking about number of people.
Yeah, it's the minimum number of people.
Mm-hmm.
And since we can't have 0.1, we got to go up to the next whole number of people. So 385 would be the correct answer. Okay, now part B says if no estimate of the sample proportion is available, how large should the sample be? Well, again, if you don't have a previous study to go off of, then you're just going to let P hat and Q hat both be 0.5. Everything else stays the same. So you'll do 0.5 times 0.5 times 1.96 over 0.04 squared. And that comes out to be 600.25. And again, we'll round that up to 601.
Cool. All right, so number 5, it says, it is believed that 25% of US homes have a direct satellite television receiver. How large a sample is necessary to estimate the true proportion of homes that do within 95% confidence and within 3 percentage points? Okay, so that's within the 3 percentage points means that our margin of error is going to be 0.03. And that's the 95% confidence tells us that our critical Z value should be 1.96. And if 25% of US homes have direct satellite television, that's like the previous, what's believed, so it's probably based off a previous study. And we'd write Q hat to be 0.75. So we have 0.25 for P hat and Q hat is 0.75. And so N is going to be 0.25 times 0.75 times 1.96 divided by 0.03 squared. And so when we enter all that into our calculator, we should get about 800.3. And again, because we're dealing with the minimum number of people, we need to round up to 801. So our sample size should be at least 801 people in this case.
Yeah, and I'll just point out, this is like one of the most widely missed questions. And it's just simply because of how they word the margin of error. So do you see how they put like 3 percentage points instead of using like the symbol for percent? So because of that, the vast majority of students will just use 3 as the margin of error. So just watch out for that, because you don't want to get this wrong. You don't want to get the entire question wrong just because you didn't realize that 3 percentage was the same thing as 3%, which means it needs to be 0.03. So.
Yeah. And I think just having 95% confidence next to the 3 percentage points kind of confused me too as I was reading it. So it's just, you know, kind of a poorly worded question overall.
Oh, definitely. They should at least be consistent with how they write things, but I didn't write the question, so.
Well, my battery's dying, so I'm going to say let's do this very quickly. So how large a sample is necessary if nothing is known about the proportion? So instead of having P hat be 0.25, we just put P hat to be 0.5, and then Q hat is 0.5, and then do the same calculation, and we get 1,067.1. And so we round that up to a minimum of 1,068 people to survey. And I think that's it for this section.
That's the end of the section. That's the end of the chapter. And yeah, I don't have anything else to add. So
thanks, Karen. I'm going to go run and get my charger.
Okay. Bye, guys.